Hello, thanks for accepting this work. My name is Bushala Afaf. We will present this work under the title Study of the Structural Composition of one of Rocks from Ouargla region. A work plan. The introduction. The target. Method and devices used. Findings and discussion. The conclusion. The introduction. Rocks are the structural unit of the Earth's crust, and rocks are defined as a solid, coherent, inanimate substance naturally formed from one or more minerals, and rocks vary in terms of their properties and their constituent minerals. There are a number of types of rocks that were of utmost importance to humanity, as they are used in construction and electronic works, and the importance of rocks is not limited to their economic summit only, but they are of scientific importance as well. The target: studying a rock sample from the Ouargla region and determining the chemical composition of this sample and those exploiting and benefiting from the various materials it contains in many new technological applications. The method of work. Take the sample. Sample preparation. Spectroscopy methods. Take the sample. We took a sample from Ouargla, where we collected a certain number of rocks, and these rocks differ from each other and have different size and colors. And in our study, we took a sample of white rocks. Sample preparation. The sample preparation process went through two consecutive stages. The polishing stage. Get rid of the impurities accumulated in its outer layer. Place the sample surface on the raw surface to be polished. A more pure sample than before. The milling stage. The sample was crushed well with a mechanical device. Grinding continued for about a quarter of an hour. Get rock very soft. To avoid influences from moisture, the sample was kept in a sealed plastic container. Spectroscopy methods used. X-ray diffraction technology (DXR). The technique is used to detect crystal structure where X-rays are shed on the sample, and then the matter receives the diffracted rays and draws the diffraction diagram. Sample preparation. The sample is placed in a holder, then manually pressed with a plate in order to obtain a surface. X-ray fluorescence technology (XRF). This technique is used in the detection of chemical elements, where when X-rays are shed on the sample, one of the electrons is lost. Radiation is emitted and it is monitored by the matter, and then the element is detected. Sample preparation. Place the milled sample in the holder designed for the device, and then press the sample with a plate to acquire a flat surface. Infrared spectroscopy (FTIR). This technique is used to discover chemical bonds, and this technique depends on the vibrational energy of molecules, where the beam of radiation of all wavelengths is sent from the source to the sample, and then the detector is treated with an immediate transfer to give the required spectrum. Sample preparation. We put 1% of a sample powder with 99% of potassium bromide (KBr) in a pestle, and the grinding is done. We transfer the mixture to a compressor and distribute it to the holder. Apply a pressure to obtain a transparent tablet and place the disc in a spectrometer for measurement. Results and discussion. Results of the X-ray direction technique. The direction pattern of the studied sample was obtained by an X-ray direction device. This diagram was processed by high-score software. It was found that this sample consists of three crystal phases: a rugidate, coicite, and low-widget. We estimated the proportions of these compounds in the rock sample, which are as follows. Results of the X-ray fluorescence technique. The table shows the chemical elements and their constructions, where we observed the presence of aluminium at a rate of 45-18%, and we noticed the presence of magnesium at a rate of 28-48%. Infrared spectroscopy results. This represents of transmittance spectrum in terms of the wave number, and the results were recorded in the following table that represents the frequencies and the corresponding factual groups, where we observed the presence of SiO functional group and knowledge of the compounds in quartz, and we also found in this sample other functional groups, and it is not possible to prove the presence of a compound in the sample is because no previous studies have studied these materials. The conclusion. Through our work, we were able to determine the chemical compounds of this rock sample using spectroscopy methods of decomposition, and it was found that this sample consists mainly of three crystalline phases: a rugidate, coicite, and low-widget, and it also contains chemical elements such as aluminium and magnesium. Hence, the various constituent materials can be taken advantage of and exploited in new technological applications. Thanks for the good follow-up.